Okay, so lesson 5.1, homework help. So this is all about inverse equations. Inverse equations, all right? So the first one, you're asked to find the inverse equation for all these situations. So remember, when you're working with these, you want to figure out first what are the steps to solve for x, or solve for f of x if you were to be given an input, right? So if I gave you an x to plug in here, what would you do first? Well, the first thing I'd do is I'd multiply 3. What would be the next thing you do after you multiply 3? Well, then you'd subtract 8. So now to find the inverse function, I'm sorry, guys, I'm doing the wrong one. So I'm actually paying attention to this one. So first I'd multiply 2, and then I'd add 5. So that's what you would do if you were just doing the original function. Now to find the inverse function, you do the reverse and opposite function of that. So if I first start with the one on the bottom, and if I add 5, that means the first thing I do is I subtract 5. And then the next thing I do is the next one in order. If originally I multiplied 5, well, I do the opposite now. I divide by 5. Divide by 2. So now I always start with my inverse function by saying f of, I put the little inverse function sign there. Okay. It will be equal to, first I'd say x. The first thing I'm going to do is do x minus 5. And then what I end up doing after that is dividing everything by 2. So there's my function. Now if I want, I could divide the 2 into both of these terms. I can leave it like this. This is fine, but I could divide the 2 into both of these, and it looks like this, x over 2 divided by x, and then 2 divided into the 5. So I could write it either way. Preferably I'll do it this way. Maybe if I need to graph it with this type of function, I would do it this way. Okay, because that's y equals mx plus b form. Okay, now same thing here. At first think of what's the first thing I do here? Well, that would be, now, what you need to realize is that even though I'm multiplying 1 over 3, this is the same thing as writing x over 3. Okay, so really what I'm doing here is dividing by 3. So anytime you see these fractions, just know you're dividing by whatever this is, okay? And then I subtract 5. So to get the inverse function inverse, I'm first going to do the opposite of the last one, which is add 5 now. So x plus 5. And since before I divided by 3, now I'm going to multiply 3. So I multiply all of this times 3. So I can leave it like that, or I could write it, I could go ahead and distribute and then write it like this. Okay, so that's basically just simplifying it so that I end up with, those are equivalent. 3 times x plus 5 and 3x plus 15 are pretty much the same. Okay, so now this one, again, what would I do first if I plugged in for x? First, I would subtract 4. Then I would divide by 5. So to get the inverse now, I first start with this operation. I do the opposite of that. So first I'd multiply 5, and then I'd add 4. So now my inverse function, well, first I multiply x times 5, so 5x, and then I add 4. So there you go. There's your inverse function. Okay, so again, for all these, you're going to do the same thing, but with the function that you've been given. Okay, so now we got this situation dealing with function machines again. And by the way, for your guys' problem, this is the square root of x plus 5, in case you can't see that. Okay, but again, we're going to use x minus 7, square root of x minus 7. So Krista was working with the function machine shown here. This is the one we're going to look at. But when she turned her back, her little brother Caleb dropped in a number. She did not see what he dropped in, but she did see what fell out. Now for your problem, 9 will fall out. For our problem, 5 is going to fall out. And we'll say fell out, that's basically the output, right? So what operations must she perform on 9 to undo her machine? Undo her machine did. Use this to determine what the number Caleb dropped in. So basically, we're going to do really similar to what we did up here in undoing the function so that we can figure out what was the number that you dropped in order to get 5 out of this function. Okay, so instead of like trying to plug this in, we're just going to work backwards. Okay, so here, what we'll do is first we're going to figure out what the inverse function is. And I'm sorry, that should not be like a inverse symbol there. Okay, it's just k of x. Okay, so first, what are the operations we do if we just had the input, right? Well, first we would subtract 7. Then after we subtract 7, we end up taking the square root of that number. So we take the square root of whatever's inside. Okay, so to get the inverse function, we're going to work backwards here. So now here, the opposite of square root, opposite function, is to square something. So x squared. And then after that, instead of subtracting 7, we're going to add 7. So we're going to use that to help us figure out what is the number that he dropped in. So remember, we're using 5, right? So we're basically going to take the output of 5, and the first thing we're going to do is square it. We're going to do 5 squared, and then we're going to add 7. So now 5 squared is 25 plus 7. So then I know the input must have been 30. What is that, 33? Oh, sorry, no, 32. And I can double check that. If I plug that in, right, 32 minus 7 is 25. And then the square root of 25 is 5. So I know I'm right. All right, so now I'll write the equation. Well, first I'm going to use that same k and put the little inverse notation there. And then I'm just going to use the steps that I came up with here. Well, first I'd take my number and square it, and then I would add 7. And there's your function. Okay, so now you're going to do the same thing with that function. Okay, so now here, this is review. A little bit of review, then this part will be finding the inverse. So here we're going to be evaluating. Remember, pay attention to what function you're supposed to be doing. So here it says f, so I'm going to take this number and plug it into f. Again, I'm using these functions instead. And this one, you would take that and plug it into g. So here, first f of -7, I want to plug -7 in there, into x. And then basically what I'll do is I'll work that out. First, I'll multiply the exponent. I'll do exponents, then multiply 3, then add 2. So again, I plug that in again, and after I figure out what that number is, I write f of -7 equals 149. Now I'm going to do the same thing, but I'm going to plug in -2 into now the function g. So I'll set it up with 2 times -2 minus 4. So then I'll just do this one real quick. 2 times -2 is -4. Then minus 4, that's -8. So we're going to write g of -2 is equal to -8. Okay, so now this one, it's saying f of x equals c. So not a number, but just a letter. What is x? Well, first of all, if it's saying f of x is equal to c, that means that this part of the function right here is equal to c. So let's replace that with c. So c equals 3x squared plus 2. But then it says, what is x? So basically what you need to do for your equation is solve for x. So we're going to need to get x by itself. So what we're going to do first is we're going to take this 2 away from both sides. Okay, so now we have c minus 2 here, and then 3x squared here. And now we need to get rid of that 3. So we'll divide both sides by 3. Bring this up here. So that cancels the 3. So now we still have this c minus 2 over 3 equals x squared, but we still have x squared. We still have this exponent. So to get rid of that, we're going to square root both sides. Okay, so that means the square root of c minus 2 divided by 3 is equal to x. And that's it. Once I get that by itself, then I'm done. Okay, now I'll do the same thing here with g of x. Plug in the c. This one will be a little easier because it's a linear function, not a quadratic. Here I'm going to add the 4 both sides. C plus 4 here, 2x here, and then I'll divide both sides by 2. Bring this up here. And now I have c plus 4 divided by 2 equals x. Okay, so again, once I plug that in, I'm just solving for x, and I have like a new a new equation there. Okay, now it's time to find an inverse. So if you see that, oh, and I apologize, guys, I haven't been writing right notation. These should be -1s. I've been doing that this whole page, and I haven't included the -1 in the notation. Because actually, if you only write a 1, that actually means something else. That's prime, and that's actually in calculus, if you guys end up taking calculus. Or sorry, not prime, but it's a derivative. Okay, so here, we're going to look for the inverse. So again, let's take those same steps. So we're going to figure out what would I do first here. First, I'd multiply 2. Then I would subtract 4. So then to find the inverse, I'm going to go backwards and do the opposite. So first start with the last one. So I do add 4 instead of minus. And since I multiply 2 here, I'm going to divide by 2. Okay, so that means that g of minus 1 of x, g minus 1 of x is going to be equal to first x plus 4. I'm going to add 4 to x. Then I'm going to divide everything by 2. And then another way I can write this, so that would be acceptable, is I could divide 2 to both of these terms, and I get x over 2 plus 4 over 2, which is 2. So in case I needed to graph it for whatever reason, then I can put it in that form, or I can leave it in that form. Okay, so let's go down here. So again, now we got some more problems that we're going to be doing inverse. So if you read this, it's this, again, another brother and sister problem, and they're constantly undoing one another's work, and the brother ends up undoing all her functions, right? So we're going to help him undo these functions, which just basically means come up with the inverse function of each of these, okay? So first we got to figure out, okay, same steps as before. First I would multiply 2, and then here, and then subtract 7. So then when I do the inverse, first I would add 7, then divide 2. Okay, so that means that y to the -1. Okay, notice how it doesn't have x, so I just put y to the -1 without the of x part of it. So it would be first x plus 7, then divide by 2. And again, I could split that like I did here. I'm not going to, but again, if you needed to, you can. Okay, so now here, first thing I would do with this function is I'd take x and then subtract 5. Then the next step after doing that is I divide by 3. So then my inverse function, I would start by multiplying 3 and then adding 5. So y inverse would be first 3 times x and then add 5. Okay, now in this one, first thing I'd do is I'd raise this to the 4th power. So I take my number, and I'm just going to write x to the 4th because I'm raising it to the 4th power. And then I would subtract 2. On the inverse, I'm going to add 2 first. But here, remember, the opposite of raising something to a power is to find the root of that. So if you're cubing the number, you would find the cube root. If you're squaring the number, you'd find the square root. But if you're raising to the 4th power, we would find the 4th root. Okay, so this is how our inverse is going to look like. So it's going to be first, again, we're going to start with the plus 2. Okay, so we're going to do our number x, and then we're going to add 2 first, and then we're going to take whatever we end up with there, and we're going to find the 4th root of that. Okay, so there's your inverse function. Okay, next page. Okay, so here's some inequalities like we did in the last lesson for review. This is from the week before. So first we're going to graph these functions on the graph. Now notice this first function, that number does not graph on here if I go by ones. So what I'm going to do is I'm going to change the scale instead and go by twos. So if I go by twos, this would be 2, 4, 6, 8, 10. So I'm just going to label every 10 so I don't have to write in every single number. So all the way around here, I'm going to go by tens. This is obviously negative 10. Actually, it's right on this side. Okay, then over here would be negative 10, negative 20. Okay, so here we start at 12 and we go up 3 over 1. Okay, and now again, pay attention that we're going by twos here, right, on the scale. So that means that any value in between would be 1. So if we start at 12, which is here, we're going to go up 3 over 1. So up 3, 1, 2, 3. And then we're going to go over 1, which remember that down here, that right in the middle, that's a 1. So I go up 3 there, and then right in the middle would be 1. Do the same thing again. So up 1, 2, 3, and then over 1. We'll go there. All right, so I'll go down a few more just so I can get a straight line here. We'll go down 1, 2, 3 over 1. 1, 2, 3 over 1. And that should be enough to at least finish my line up first. So remember again here on this first one, this is going to be a dashed line. This will be, I'm sorry, solid line, and that'll be a dashed line on this one. So let's make my solid line on the first one. Use my trusty box here since I don't have a ruler. All right, so in this one, again, now we're going to start here at negative 5. And this would be negative 4, so negative 5 would be right there. And here we're going to go down 2, then over 3. So down 1, 2, and then over 1, 2, 3. So about right there. We're going to go down 1, 2, then over 1, 2, 3. I'm going to do it one more time. Down 1, 2, and then over 1, 2, 3. Okay. Now I can make a straight line. And remember, this is going to be dashed. Just take whatever straight edge you got. You could take another pencil, the edge of a book. Sometimes I even take like little tiny books from my kids' Lego books. I mean, you can just grab whatever has a straight edge on it and make yourself a straight line. Okay, so there's your dashed line now. Now again, remember when you have inequalities, you got to shade it. So on the first one, we're going to shade above. Second one, we're going to shade below. Solid line above, since it's leaning to the right, above will be here on that line. So we'll shade lightly, and then we'll shade the darker area where they overlap. And then we're shading below the dashed line. So that would be here. So you can see that the overlap is there in this corner. So kind of just make that area a little darker than the rest. Okay, so now in this one, again, same thing. Let's actually start with this one because obviously this one's just a straight line. So that's simple to draw. And this will fit on the graph. We don't have to worry about changing the scale here. So we're going to go start at 1. We're going to go up 2 over 3. And keep going. So up 2 over 3. Up 2 over 3. And we'll go down. We'll go the other way as well. Down to left 3. Just so we can get some more points in. Down to left 3. Down to left 3. Okay, so this one's going to be dashed. This one's going to be solid. So this one, first one I made, the straight line will be dashed. Again, I'm starting with my linear line, the straight one. And notice how your first one's going to be a quadratic. Now, to graph this, I could go on Desmos. What I'm going to do that you guys did last week is complete the square to figure out the vertex. Now, right away, I know that is the y-intercept in standard form. So let's go ahead and graph that. at 0, minus 5. So I'm just going to pass through that point, but I want to know where the middle of the graph is. So I'm going to kind of go down here and show you guys quick steps on figuring out the completed square of that. So here I have y is greater than x squared minus 4x. And remember, I'm going to complete the square by dividing this by 2 and then squaring it. So that'll be 4. And I put that part in parentheses. And I keep that negative 5 outside. Remember, whatever you add here, you also subtract to this number. So that'd be negative 5 minus 4. And then I want to factor this. And remember, if you guys remember the shortcut here, I basically take half of that number. So if it's negative 4, this will end up being x minus 2 once I factor it. And then negative 5 minus 4 is negative 9. So then my vertex is 2 minus 9. So here, and again, guys, if you want to go on Desmos and find that point, that's fine too. Okay, but that's another way to figure it out. So 2, so I go over 2, then down 9, down to here. And this is a positive parabola, so I know it's going to go up. And what I'm going to do is actually do the line of symmetry here, because then that way I can kind of repeat this y-intercept over to the right. It's to the left from the line, so it's to the right as well. Okay, so that's enough for the parabola. So I'm just going to kind of do my best to make a nice line here going up. Remember, this one's going to be solid. Okay, and since we're shading, I'm actually going to go all the way to the top of the graph, because sometimes you might have to shade around that parabola. So let's go all the way to the top here. Okay, so now here on the parabola, it's shade above. It says y is greater than. And y is greater than, if that's the vertex, I go above the vertex. So that means everywhere inside of here is where I'm going to shade for the parabola. So now I'm going to decide, is it above or below? Okay, well, I look at the next graph. It says y is greater than. So that means I go inside the parabola and above the line, which would be right here. So your solution could be anywhere in that dark shaded area. Okay, now on this one, you only have one inequality. So you're just going to graph that inequality and then shade on one side of it. Now, if you remember, that's a cube function. So that means I'm going to get kind of that function that looks like this. Goes down one way and up the other. And so the middle of that function right here comes from those numbers inside, which would basically be 1 and 0. Since there's no number out to the right, it's just that locator point, that point in the middle is at 1, 0. So I'm going to go and graph that. So it'll be right there. We'll just kind of make that point up there. And I'm just and this is, again, it's going to be a dashed line. Pay attention to yours. Yours end up being solid. So this, I'm going to kind of just come up and make a quick sketch of it. Come in here, going down to the left and then up to the right. And actually, let's continue that up a little further. Now it says y is greater than. So I'm going to start at the locator point and figure out where is greater than. Well, greater than would be above this point. So that's up here in this area. So that means on this side of the graph, I'm going to shade. Okay, so your solution can be anywhere in this area here. Okay, so now on this one, I'm going to use this function to figure out all of these. Again, this is similar to from the first page. So I plug in that 5 to the function. Five goes in there, so 5 minus 3 squared. Pretty simple. So just 5 minus 3 squared is 2. 2 squared is 4. G of 5 equals 4. Okay, now this one, I'm going to be plugging in this whole thing. I'm going to plug in 2m plus 4 into x, all of that. So 2m plus 4, and I still have to subtract 3 after that. Okay, so now 2m, 4 minus 3 is 1. So then I end up with 2m plus 1 plus 1 squared. So let's simplify that by expanding this out. Now we have 2m plus 1, 2m plus 1. And then what I want to do is multiply all this out. So I can use the box for that. 2m1 here, 2m1 here, and then multiply everything inside. And I have 4m squared here, 2m here, 2m here, 1 here. So then I end up with g of 2m plus 4 equals, first of all, I have 4m squared there. Then I add up the like terms. Those two are like terms, so 2 plus 2, 4m, and then your last term, plus 1. So that is the new kind of equation there. All right, so now here, solve for x if g of x equals 9. Okay, so that means I'm going to plug in that 9 there. So I'm plugging that 9 there. Now, if you guys remember, when you have a problem that looks like this, where you have this kind of squared part on one side, and you're solving for x, I can square root this to get rid of that squared. So square root both sides, and then I end up with x minus 3 here. And remember, when you square root a number, you need to account for the fact that it could be positive or negative. So plus and minus 3. And now what I want to do is separate this and solve this twice, because I got a positive and a negative result here. So first we'll do positive 3 equals x minus 3. And then we'll solve for negative 3 equals x minus 3. So obviously on both I'm going to add 3. On one, I end up with x equals 6. And here I end up with x equals 0. Okay, so the last one. So here are the it's saying use the graph of absolute value of x plus 2 plus 3 to solve equations. So let's use the graph. So what we're going to use is actually go to Desmos, and first we're going to graph this function, x plus, or the absolute value of x plus 2 and plus 3. X plus 2 plus 3. So there's our function there. And now what we're going to do is we're going to be looking at these different situations. You notice how in all the problems it starts off with that function. So for you guys, x minus 3 and then plus 1 on all of them. Okay, so in the first situation, it's going to be x plus 2, absolute value of x plus 2 plus 3. Basically, you're solving for this problem. When will this function equal 3? So the way we're going to solve that is basically when will the function, this function above, equal 3. The way we'll do that is I'll type in y equals 3. So basically, when does this function here line up with the y value of 3? Right there at negative 2 and 3. So that's my solution for that one. Negative 2 and 3. And notice how it says equal, so I only get like one solution here. But here, inequality means I'm going to have a range of solutions. So now this is saying, when will this function, x plus 2, absolute value of x plus 2 plus 3, when will it be less than 8? When will it be less than or equal to 8? So the way I'm going to do that is actually I'm going to type in, when will y be less than or equal to 8? Okay, so you notice that this shaded area is where this function, the v, is equal to less than 8. So that starts at negative 7, and it goes all the way down here as I keep increasing x, and it's still less than 8, still less than 8, until I get to that point at 3. So it's less than 8, starting at negative 7, and then ending at 3. So starting at negative 7, going all the way to 3, it's going to equal less than 8. So in this case, it could be greater, the function will be less than 8 when x is greater than negative 7, or when it's less than negative 3. Okay, so now this is kind of similar to the first one. When will it equal 5? So I go over here. I'm going to write y equals 5. When does it equal 5? It will equals 5 at negative 4, at x equals negative 4, and at 0. So at x equals negative 4 and x equals 0. That's when this function will equal 5. Then the last one is, when will this be greater than 4? So I kind of do the same approach. When will it y be greater than 4? Okay, so again, anywhere in the shaded area is a solution, right? So as I'm coming down here, until I get to -3, once I get to -3, it's no longer a solution because down here on the graph, it's not in that shaded area anymore. So from -3 until I get back to -1 all of a sudden. So for instance here, -2 wouldn't work. Okay, so when it's -2, it's not going to be greater than 4. Or when it's like right here, which is like, I don't know, that's -1.5. Here over here is -2.5. Anywhere in between the -3 and the -1 will not work. It will not be greater than 4. So that means that x has to be either less than -3 or it has to be greater than -4. So let me show you how to write that. So I said that x has to be less than or equal to, actually it can't be equal to, because you notice it has a dash, there's a dash line there. So it just has to be either less than -3, or instead of writing it together like this, we write or greater than -1. Okay, and that's it.